Hello everyone, my name is Austin Plummer, and today I'll be presenting my final presentation for COSC 6570 Data at Scale at Marquette University. This presentation will be about a solution called WellFed that is going to be a mobile application that will address issues in health and nutrition through the use of big data. So let's start just by framing the overall problem. Maintaining productivity and adopting healthier eating habits have become increasingly more difficult in today's fast-paced world. These issues affect individuals and organizations. As we can see through children, the lower academic performance has been directly linked to poor habits like increased screen time, which impact productivity levels. And for adults, billions are being spent on self-improvement without addressing the actual root cause of lack of productivity. And while there may be many reasons why someone can't maintain productivity or is struggling to be productive, nutrition has been proven to be directly linked to productivity as one of the main reasons for poor productivity. Research tells us that poor nutrition has severe consequences. This can lead to depression, impaired memory, and increased risk of chronic disease later on in life, as well as the growing epidemic of obesity, which is impacting 1 in 5 adults across the U.S. In the year of 2023. So WellFed addresses this problem head-on. By combining cutting-edge technology and a scalable data architecture with personalized insights, this app will empower users to overcome healthy eating barriers. These barriers can be things such as time constraints, limited cooking time, lack of skills, restricted access to food, or just the monotony of meal prep, getting bored of the same meals. And we want to help address this issue for our users. So the app will deliver personalized recipe recommendations tailored to users' dietary preferences, their health goals, and their available ingredients. So in short, WellFed makes healthy eating simple, accessible, and sustainable for everyone. So to build out this data architecture, we have 6 key data sets. So the first data set is going to be this recipe data set. We currently have over 1.5 million recipes that are pulled from different web resources as well as APIs and just different information from across the internet. And so this data set is going to outline the recipes available for users to actually eat. And so we'll show the recipe information, like the ingredients, the directions, but also just build an overall nutritional profile for each recipe, understanding how many calories in that recipe, the fat content, the protein content, whatever it may be, and then providing a recipe review and rating so users can kind of see how this recipe stacks up to other recipes. The ingredients data set currently consists of over 100,000 different ingredients from the USDA and other resources as well across the internet. Will continue to grow and outline the different ingredients utilized in these recipes. So we can see the kind of nutritional profile of each ingredient and then use that information to build out the nutritional profile of each recipe. Then we have the user profile, which is going to show us the users, the information about the users within our system. And so being able to understand what kind of users are most utilizing the system and understand how we can appeal to those users or attract new users, but also being able to provide calculations for each user by taking in their height, weight, age, gender, and other biometric information that we can use to then build out the nutritional profile for themselves. User activity is going to be key to the recommendation part of this application. And so understanding how the users are actually using the app, understanding their eating patterns and their eating habits, just getting an idea of what they're eating on a regular basis will allow us to build out a recommendation for the user themselves. Shopping list data is going to connect information about ingredients to the local grocery store inventory, allowing users to kind of find ingredients they may be missing or be able to kind of build out a shopping list for themselves. They can see their previously used shopping list and just kind of have an idea of how their shopping trends are kind of progressing over time. And lastly, the feedback data is going to allow us to get an understanding of how the users are utilizing the application through their actual feedback. And so being able to get their ratings on each recipe, understanding what they like versus don't like within the actual application itself, is overall getting a feel for our users and how they like the application so that we can continuously build out more of their recommendations and improve the app over time. And so I alluded to some of this in the actual description of each database, but essentially each data set itself just provides a small snapshot of the actual application or of the actual user. Being able to connect these data sets to one another is what's really going to allow us to paint the full picture of each user and how they're actually going about their day-to-day lives. So connecting ingredients to recipes and connecting those ingredients back to a shopping list, which then connects back to the user and kind of understand the user activity and seeing how all these things connect to one another. We can really get a full picture of how the user's going about their day-to-day life and building out that recommendation for them based on their habits and their frequently used how they're frequently using the app. And so this conceptual schematic kind of alludes to that same concept, taking in these data sources, these data sets, running them through these different layers of our data architecture, which I'll go in more detail to in the next few slides. And then just getting the overall outcomes of personalized recommendations for the user and improved quality of life and health. And so this is really the goal of WellFed, to take this information that is more complex and provide simple solutions for our users. When looking to build out this data architecture, the priorities of availability and partition tolerance were deemed most critical. And so the reasoning for this is because as an application that's going to be very user-centric, we want to make sure that it's available to users at all times. So any delays to the user, any servers going down, not having much impact on the actual user experience is going to be very important. This is because for an application like this, where something is like nutritional tracking is very important, when a user is not able to access the application or not able to track a meal at the time of them actually eating it, they're much less likely to come back and do that later. So if we don't have information that's accurate to the user's actual patterns and eating habits, the recommendations we provide them will not be as valuable to them either. And so making sure that the user is actually able to access the information or actually able to input the information at the right time is very important to make sure that they're actually using the application to its fullest capabilities. While consistency may be important in some other areas, eventual consistency is very much tolerated in our case. Nutritional data is not going to change very often. Recipes, ingredients are not going to change often. The nutritional profile of an ingredient is not going to change often. And so that information will have to be written to the system very often. The only thing that will really be updated on a regular basis is going to be like the grocery store inventory. That's the only thing that will really have changes on a frequent basis. But a workaround for that is having the ability to provide alternate ingredients for each recipe, and also provide multiple different grocery stores to find inventory at. And so being able to kind of work around that issue is going to be the way that we cover up any kind of issues with consistency, which in itself will be very minimal. And so a cloud database architecture allows us to really address this issue. So we want to utilize services like AWS, Azure, and Google Cloud, which are very well known and very well built out cloud providers. They will allow us to elastically store data, elastically scale data. As I mentioned, there are currently already millions of recipes and millions of data points in this data set, but that will just continue to grow to billions and trillions of data points. And so being able to have a place to store this information is very important, and will also help to maintain optimization of costs, as we won't have to pay for continuous upgrades of servers or purchasing new hardware to store this data. It can all be stored elastically through the cloud. So also help us to tackle the issues or the priorities of availability and partition tolerance, as the cloud is able to partition data and partition tasks to different regions and zones. And so we can do things like spread out the load of each processing or of the algorithms, and also provide information to users closer to their home. So for example, if a grocery store inventory for a local grocery store needs to be quickly accessed by a user, that information can be stored in a region that is closer to that user. And then lastly, just having the capabilities of the cloud to protect data and protect our users is going to be very important as we gain more and more user information. So let's look at Anthony. Anthony's user persona we're going to focus on in this presentation, kind of walking through his difficulties in his life. He's a typical user of WellFed. He has a 9-to-5 job. He is working on a regular basis, trying to be productive in his job and advance in his career, but also has goals in his personal life. Wants to retire his family, wants to build a family, retire his parents and build a family. But he kind of struggles with eating healthy and doesn't really know how to do so. He doesn't have the time for it. He doesn't have the knowledge to actually cook well and find healthy meals, but he really has a desire to do so. So Anthony, as a user, will simply come into the app and input his ingredients that he has in his kitchen. And we'll walk through how that information is then processed in the actual layers of the data architecture. The first layer being the key value store. This will act as a caching layer, meaning that it will be a layer that allows us to retrieve information that is frequently accessed in a much quicker manner. So for example, as Anthony inputs his ingredients that he has available, we can easily pull his dietary preferences, his allergy restrictions, and just his preferred meals or preferred recipes that he may have in the system, and be able to pull those easily for the algorithm to then use to build out the recommendation for him at the moment. Next will be the wide column database. So this will organize ingredients into clusters. And so we can find ingredients that have similar nutritional profiles, have similar recipes that are utilized in, or that are found at regional and national suppliers, and be able to provide that information in a much more manageable framework, And so for this example of Anthony, when he goes and puts his information into his ingredients into the system, we can cluster recipes that utilize those ingredients and connect them to the shopping list that he has with the real-time grocery stores availability. And then we have the NoSQL graph database. This is going to be the core of the architecture, the core of the system. And so this is really going to fuel the recommendation algorithm that's underlying in the system. And so for Anthony, we can kind of map the relationships between his ingredients that he specified in his input to recipes that are utilizing those ingredients, and then map those recipes to his health goals, seeing how the nutritional profiles line up with his actual goals. And so then the graph on the right is kind of showing how we can connect this is an example graph connecting the user itself to the different ingredients and recipes and inventory that he needs to actually build out that recipe itself. And because we're using such large-scale data, a MapReduce is going to help us to kind of process that data. So we'll leverage MapReduce to process large-scale data efficiently. For example, it will organize ingredient consumption data and simplify it into actionable outputs, like identifying frequently consumed ingredients or clustering recipes by user preference, just overall reducing the information into much more manageable loads of information and spreading out the processing of that data to different nodes so that it can be all done efficiently and quickly without overloading any kind of part of our system. And so ultimately, as Anthony goes through that database architecture, or as Anthony's data goes to that database architecture, he will simply just get back tailor meal plan within seconds. So he won't see all the complexity underlying within the data architecture. He'll simply just get back his result, which as a user is all you want. And so not only will he have a tailored meal plan, but he'll also have alternate meal plans, alternate recommendations for the meal plan built by the algorithm, so he can continually update or edit that meal plan as he wants to. And then the system will continuously learn from how he's inputting and maneuvering through the system itself, and be able to build out more tailored recommendations over the course of time. So the overall goal here is to address the idea of supporting healthier eating patterns. And so we want to help users to improve their productivity, but also just eat healthier as overall. So WellFed's value goes well beyond the user itself. For corporate stakeholders, the app offers measurable returns. A Harvard study found that wellness programs so investing in wellness programs has a return on investment of 6-to-1 by reducing healthcare costs and absenteeism. So by addressing a root cause, nutrition in this case, WellFed supports not only personal but organizational activity as well and productivity. This project will also demonstrate the power of the innovative scalable data architecture in solving real-world problems. While we may have considered some alternative methods, we ultimately just stuck with the NoSQL graph database. The alternatives that were explored were a NoSQL document database or a hybrid system combining the NoSQL document and graph databases themselves. While the document database excels at handling diverse data formats, it lacks the ability to kind of find relationships between data and do relational analysis, which is a very critical part of our solution here. And a hybrid system between the two, while it offers flexibility, increases the overall complexity of the system and therefore increases the operational costs. And so ultimately we chose the graph database architecture because it best aligns with the goal of creating a system that uncovers relationships to deliver meaningful insights and outcomes for our users. WellFed's value goes well beyond the user, and in short, it's not just an app. It's a solution to a critical issue. It leverages cutting-edge technology, personalized insights, and a robust data architecture to make healthy eating accessible and achievable for everyone. Supporting WellFed means investing not only in a healthier and more productive future for individuals, but also for organizations alike. And so WellFed will serve as a solution to the overall issue of productivity and health and nutrition by utilizing a data architecture that robustly and effectively addresses this issue for all. Thank you.